All right, so let's check out practice 12.3 and looking at number 1 here. So let's check out our function. And the first good thing to recognize here is we have a polynomial inside a polynomial. So the inside function we'll define as u. And then that changes our function y to just being then u to the fourth. And now we'll take these derivatives. So we're doing the chain rule here because ultimately we want the derivative of y with respect to x. And the chain rule says, well, if you've got two different letters, then you have dy over du times du over dx. So we want the derivative of y with respect to u. So here's y, and its derivative with respect to u is 4u cubed. And so that's what goes right here. And then we want du dx. So here's u, and we want this derivative with respect to x. And I actually don't have enough room there, so let me just write it right here. So looking at this derivative, the 4 drops down. So 4 times 4, 16 x cubed. And then the 2 drops down. So 2 times minus 6 to get us a minus 12x. And the derivative of a constant is a 0. And there's our chain rule. And then our last step is to plug back what u is. U is 4x to the fourth. And there is our derivative. So number 2, I'm going to skip putting any answers in for these since that takes a little longer to type in those answers, and I'm sure that's pretty boring, me just watching me type those answers in. Well, let's look at the second one. So here's our function. And again, we have a power function inside a power function. So what we're going to do is we're going to define that inside function as u, which then makes our entire function s now 44u to the 6/5. And now both of these derivatives we can do. So the chain rule says if you want the derivative of s, now the input variable is t, so that means we're taking the derivative with respect to t. So remember, ds dt, this is s prime, the derivative of s. And the chain rule says that this equals, in terms of another letter, u, we get the chain rule. So we want the derivative of s with respect to u, which is right here. So we'll have 44. So the 6/5 will drop down. We subtract 1 from the exponent, so that's minus 5/5 to get us a 1/5. That is ds du. Now we want the derivative of u with respect to t, and that's right here. So we'll take this derivative. So the 3 will drop down. 3 times 8 is 24 t squared, and the derivative of minus 7 is 0. And so here's our answer. We'll plug in what u is. So we defined u to be 8t cubed minus 7. And that's our answer. Now to enter this into MyMathLab, we would want to clean up these numbers here. Now these numbers are pretty large, which means you'd probably use your calculator. I would use my calculator for these numbers. And that's our answer. So now they're giving us m of t, so they're going to mix up the letters here to challenge you to make sure that you're understanding the chain rule correctly, so it's not just terms of f and x. So now we have m of t. We have a minus 7t. So the first thing to notice is that there's more here than just the chain rule. So in the parentheses is where the composite function is. You have 2t cubed minus 1. This is a power function inside this power function. And all of this is being multiplied to another power function. This is a product rule with a chain rule. So we'll define f and g like we normally do with the product rule. And we'll take these derivatives. So the derivative of f minus 7t is minus 7. Now the chain rule is on the derivative of g. So let's look at g. If we define u to be the inner function, then g is just u to the 6. And the chain rule says that the derivative of g, now remember our letter here is t, that's the variable name t, so this is dg dt, that is the derivative. And then in terms of the chain rule, this is going to be dg over du, d over dt. Now notice when writing the chain rule that these du's should always cancel, so you're left with the derivative, dg over dt. And so we have the derivative of g with respect to u. Well, here's g, so we'll take the derivative. That's a power pattern there. U to the 6th, the derivative is 6u to the 5th. And then it says we multiply by du dt. Well, here's u. So we take this derivative with respect to t. So 2t cubed is 6t squared, and the derivative of minus 1 is 0. Here's our answer. And now to polish it all up, we'll plug back in what u is. So we define u to be t cubed minus 1. That's all to the 5th times 6t squared. And we have a minor cleanup here. 6 times 6 is 36. And that is our derivative. G prime, 36t squared, times the quantity there to the 5th. And now remember, we're still doing the product rule. So now that we have our pieces, we can stick them in. So we have f is minus 7t. We have g prime, which is where the chain rule was. So that's all the work we just did here. So the chain rule got us a 36t squared plus f prime. So f prime is minus 7. And then all of that times g. where G then is this quantity to the 6. And this is our answer. And we'll try to do our best to clean it up. In this case, the greatest common factor will clean it up a little bit. So we can see each term has a -7 in it. And each term has at least 5 of these parentheses. So there's 5 parentheses here, 6 of them over here. And so that's our greatest common factor. And so what's left over would be 36 t squared and t will get us a t cubed. We factored out that entire parentheses there, so that's gone. And we're just left with plus 1 parentheses here. And it turns out we can now we can gather like terms even. So in the parentheses here, since 36 t cubed and 2t cubed are like terms, we can add those to get 38 t cubed minus 1 then for our parentheses. And that would be our simplified answer. So now what do we got here? We got y our inner function is a power function. This power function is being put into an exponential function. So we define the inner function as u, which then makes the outer function then e to the u. In terms of the letters given, in terms of y and x and u, we want the derivative of y with respect to x. That's what we want. That's our derivative. And the chain rule says, well, this derivative is equal to the chain rule expression. And so now we'll plug these pieces in. The derivative of y with respect to u. Here's y. The derivative of y, e to the u, is itself. And then du dx, the derivative of u with respect to x, here's u, we'll take the derivative, and that's our answer. We'll clean it up. In this case, we'll plug in what u is. I'm also going to move the constant in front because that's pretty common to do. And we'll plug back in what u is, and that's our answer. So we got another exponential function here. And again, try to notice what's happening here. We have a power function going inside an exponential function. So we define the inner function as u, which means the outer function then just becomes 3e to the u. Notice our letters are y and x here, so the derivative is dy dx. The chain rule says this also equals this expression. That is the chain rule. And we'll plug in these pieces. The derivative of y. Here is y right here. The derivative of e is itself. And then we take the derivative of u. Here is u. We'll take that derivative, and then we'll clean up our answer and plug back in what u is. And that's our answer. Actually, I think about it now. All these, I think, are in all the exponential functions are together, and I think it has all the log functions together. So we have another exponential function, and try to identify what you are seeing here. You are seeing a power function going inside an exponential function. We define the inner function as u, which makes the outer function much simpler. Again, notice our letters here are y and x. The derivative is dy dx. And then the chain rule says this derivative also equals this expression. And so we'll plug in those pieces. The derivative of y. Here's y. It's right here. We'll take the derivative. The derivative of e is itself. And then we multiply by the derivative of u. Well, here is u. This derivative is minus 8x. And then we'll clean up our answer. Minus 5 and minus 8. And then we'll plug back in u to get our final answer. So what do you see here? This is just a straight up product rule. There's no function going into another function here. We know this is the power pattern derivative, and this is the exponential derivative. There's no chain rule here. This is just a standard product rule. So once we have f and g, we get those derivatives. And then we plug them in to the product rule. F, G prime, F prime, G. Then we'll do our best to clean it up. In this case, we can get a greatest common factor to get our final answer. Now come the log functions. What do we have here? We have a power function inside a log function. We define the inside function as u, which then makes the outer function much simpler. Looking at our letters, we have f and x. So the derivative here is df dx. In terms of the chain rule, this is then df over du, du over dx. So df du, here's f. The derivative of log is 1 over u. Derivative of u with respect to x, here is u. And that derivative is 13. And then for our final answer, we'll just plug in what u is. U is 13x to get our final answer. So this one has the absolute value sign in it. And just in case you've forgotten, but the derivative of log is the same thing as the derivative of log of the absolute value. They're both 1 over x. So what do we have here? We have a power function inside a log function. We'll define the inner function as u, which makes the outer function much simpler. We'll look at the letters we have, y and x. So the derivative is dy dx. In terms of the chain rule then, dy du, here's y. The derivative of log is 1 over u. And then the derivative of u, here's u. So the derivative of u is 14x minus 5. And then to get our final answer, we'll plug in what u is. It's 7x squared minus 5x. And that's our answer. No more. Well, I suppose there is a greatest common factor in the denominator. We could maybe do that one last step. So again, let's try to recognize what's going on here. We have a power function going inside a log function. But it's actually more than that, as you'll see in a moment. So here is our power function. How do we know it's a power? Because x is in a base. Here's our exponent. This power function is going inside the log function. So we define the inside function as u, which makes the outside function much simpler. We'll look at the letters we have, y and x. So the derivative here is dy dx. In terms of the chain rule, so dy du, here's y. The derivative of log u is 1 over u. Du dx, here is u. But notice, we don't know this derivative pattern. This is not any of our 4 derivative patterns. This is another composite function, which means we have to do another chain rule on this. So this is a power function inside a power function. So we'll define the inside function. I'll just call it v this time, which makes our outer function then much simpler. Now in this case, we have u and x as our chain rule, so we're looking for du dx. And in terms of the chain rule then, this is du over dv times dv over dx. And the derivative of u, here's u. This is now a derivative we can do. That's a power pattern right there. So the 8/5 drops down. We subtract 1 from the exponent, so that's minus 5 over 5. So 8 minus 5 is 3. We multiply this by the derivative of v. Here is v. And so the derivative of v, 8 times 4 is 32 plus 7. This is du dx. Now our last step to do is to plug in what u and v are. So we said u is this composite function. So we have 1 over that composite function times 8/5. And now we have v. V we defined up here. Then finally, it's all times this last parentheses here. And that's our answer. Now, this one can be cleaned up a little bit because this is in the numerator and this is in the denominator, and those are like terms. They have common factors, maybe I should say. In other words, we can simplify these. So this is like saying, these two expressions, this is like saying m to the 3/5 over m to the 8/5 is what these two are like. And if you recall how you combine exponents like this, that you subtract when you have division, so we would have minus 5/5, which is m to the minus 1. Which means the two things I have circled here will reduce to a power of minus 1. So what do we all have in the numerator here? We have an 8 in the numerator. We have this parentheses also in the numerator. And this is all divided by this 5 is in the denominator. And remember, this minus 1, this is in the numerator. So this minus 1 becomes a positive 1 if we put it in the denominator. And that is our final simplified answer. So what do we have here? This is, again, a straight product rule like we had before. So there's no chain rule here because there's no function going inside a function. This is two functions just being multiplied. So we use product rule. Once we define f and g, we'll take those derivatives and then we'll put those together in the product rule. So we have f, we have g prime, we have f prime, and we have g. And we can clean this up a little bit. T to the 7th divided by t. This right here is t to the 6th. T to the 6th turns out to also be the greatest common factor. And there's our final answer. So the last one. So there's division. Division means quotient rule. Notice also this 4x, this is a power function inside a log function. So we're saying f is the numerator and g is the denominator. Now to do the quotient rule, we need to use derivatives. So the derivative of f is where we have the chain rule. So we'll take the inner function, we'll define it as u, which makes the outer function much simpler. In terms of the letters given, f and x, the derivative of f with respect to x, according to the chain rule, and so we'll fill in those pieces. The derivative of f, log u, is 1 over u. The derivative of u is 4. 4 times 4 is 16. We'll plug back in what u is. U is 4x. To get, then, our derivative. So f prime is, I jumped, excuse me, jumped the gun a little bit on writing the 4 down there. So that's 4 over x. And then the derivative of g, constant is 0. The derivative of 4x is 4. And then the quotient rule. We'll plug our stuff in. So f prime's right here. That's the chain rule that we just did. Times g minus f and then g prime, which is just 4. And that's all over g squared. And we'll do our best to clean this up. So in this case, the only greatest common factor we really have here is a 4. So there's a 4 here. Factor that one out. And that's about as good as our answer is gonna look. And there is practice 12.3.